Ah, man. You guys, we're about to have a lot of fun, okay? A lot of fun. I can't wait. Okay. Cool. All right. Did you do anything with these in AP? Like inverse, finding integrals whose answers are inverse trig? So this does not look familiar in any sort of way. Even better. That makes me really excited. Yeah.
Okay.
They're not that bad. And, well, they look terrible right now, don't they? They look kind of terrible. I'm kind and not the meanest person in the whole wide world. So it's possible that these rules are given to you on the quiz and on the test. Okay? So you don't need to memorize them. However, you need to be able to use them. And the first couple, you guys are going to see are not that bad. The second couple on this page are going to make you want to throw something at me. So we're going to do these two, the ones that aren't that bad. Then we'll take 5 and come back, okay? Because I got to figure out where all the snowballs are so you guys can throw them at me. I don't know how we're going to get that one down, but we really, really need to. That's not going to help me.
Well,
One of you guys is going to have it. How did you guys get it up there? Did you stand on the table?
I think it was Luke put that one. I put the one on the clock. Luke put the one.
Did you have to stand on a table to get that one up there?
Or maybe I threw it. I don't remember.
No, you did not throw
No,
it.
you tried to throw
I
it.
threw, yeah.
That feels virtually impossible to throw it when you think
Yeah.
about like points of tangency and like you're really resting on very few, like.
You have to throw it with almost no force, but still get it out there.
I almost feel like you need a lot of spin so that you have friction holding it onto. Yeah.
Maybe,
Yeah.
Maybe you need to like somehow get it like bounced off the ceiling.
Okay. All right, y'all. So, you will notice one of the things that's going to make you stand out that you may or may not be using these, okay? The first thing I would see when I'm like looking at this and I don't know what to do is that I have a constant, kind of, over two perfect squares, okay? And those perfect squares are very telling to me. Is everybody good so far? Okay, great. So then those squares are going to be part function, part constant, yes? So a squared is my function, that was 100% wrong. A squared is my constant, u squared is my function, okay? So as I'm looking at this one, I'm going to start with a squared equals 1 and u squared equals 9x squared, which means a equals 1 and u equals 3x. So far, do we feel okay? And if I do that, I can say that du is equal to 3 dx. So du over 3 is equal to dx. Are we still feeling pretty okay? Lovely. Okay. All right. So if I fill in everything I know, my dx becomes du over 3. I have my 12 up top, and then I have a squared plus u squared. The 3 and the 12 become a 4. Because, 3 goes into 4, 12. Wait. 3 goes into 12 4 times. Can you believe they trust me to teach you guys calculus when I can't do basic?
Well, yeah, you teach calculus, not arithmetic.
I like to say I teach statistics, so I get a margin of error, right?
Right.
Something like that. Okay. All right. So and then since that 4 is a constant, I'm gonna move it out front because it doesn't matter. Okay. So I have 4 times, and the minute I do that, I now have du over a squared plus u squared. And if I use that nice Miss Meister is the greatest person in the whole wide world little hint across the top, that tells me what I really have is 4 times 1 over a arc tan u over a plus c, which is really 4 times 1 over 1 arc tan 3x over 1 plus c, which is 4 arc tan.
So does it not matter that it's the denominator isn't being taken the square root of?
It's not. That's why I'm using this one.
Oh, I was just looking at the first one.
Yeah, so you're going to have to pick which of these forms we have. So like as I'm looking at this next one, this is an arcsecant one. Based off of the form that it's in.
Why is it that we have arcsine, arctan, and arcsecant?
Those are the ones you need to know, man.
It's feel a little random.
I understand why that feels random.
It's kind of
Patronizing.
I get why it seems like that to you.
Yeah. I got nothing as to. I would imagine the other ones are similar, only negative, as seems to be the case always. With the like sine and cosine are the same, only negative. I've never been asked that question before, so I don't know if that's actually true. But certainly while you guys are on break, I'll figure it out. Probably could even answer it now. Most calculus books have Nope. Have like little cheat sheets for all your derivative and integral rules right in the beginning of the book. They're very good at helping me figure out, like, write new problems. That's what I use textbooks for. All right, you guys ready to do this or what? Okay, tell me something. Yeah, I'm going to jump straight to u equals 3x. Yeah, that was just to show you guys where it's coming from. A is equal to 5. Great. Du would be 3 dx. Yeah. So du over 3 is equal to dx. Are you guys comfortable with me saying u over 3 is equal to x as well? So now, does this feel okay? Do we see anything that simplifies here? The 3's cancel, yeah? Because this is in the bottom. of the bottom, and this is in the top of the bottom. So.
Right.
Cool? Which now becomes 2/5 arc secant. This is absolute value of u, so absolute of the absolute value of 3x over 5 plus c. So I get that this isn't easy, but can we see that it is mostly just substitution steps? Okay, and I give you the rules. I can't. If I'm remembering correctly, the rules are not on the final because I'm not allowed to give them to you on the final. But on the quizzes and tests,
That's a question we can rely on.
I do what I can within the parameters they give me. But by then, you guys might actually feel like you know them pretty well. And if you want, I can give you practice sheets where you're just doing these problems and enough that you actually learn them. The last week before winter break. So it'll be, we'll talk about it as we get closer to it. So we have 2 days of bonus coverage of topics that don't need to be on a test, but I need to teach you. And then I have to assess with a homework. So you outside of this, you'll have one homework assignment. It is not entitled homework number 9 or homework, I don't know what one that one is. It is not, that one's number 9. It is not titled homework number 10. It's last homework, and then I put a little smiley face next to it. And it consists of 3 questions of stuff, like, again, I'm supposed to teach it to you, but I don't need to, like, put it on a closed notes assessment. Okay, and then the rest of the time is prepping for the final. The final's pretty evenly split up from Unit 1, Unit 2, Unit 3, Unit 4. There's no Riemann sums on it, I can tell you that much. I mean, if it wasn't on a test, it's probably not on the final, though I haven't actually compared them in a while, so I will before you guys have to take it. It will take a block period and then one other day. If you guys want to do Monday and Wednesday versus Wednesday and Thursday, doesn't matter to me. Once you take the final, you are not required to be in this room for third period. So like that last Thursday and Friday, if you guys do Monday, Wednesday, you don't have to be here. It's like a study hall, so you can sign out, whatever. Cool? All right, let's take 5. You don't have to write this down, but there's some value in it, okay? All right. And it should not surprise you that I'm doing a sidebar in some sort of algebraic way. So you'll notice like each of these is a function being squared, right? Okay. So when we're looking at this one, we don't see a function being squared because of this minus 4x, right? If this was x squared plus 7, we would just have an ugly value for a. It's the 4x that's really causing some problems. Everybody with me? So what we're going to do is I'm going to remind you of a process you did learn at one point, but it has definitely been a while. Cool? All right. So if I gave you x squared plus 6x plus something, and I want to write that as x plus something, the quantity squared. And again, because these inverse trig stuff, this inverse trig stuff is function squared, I somehow have to rewrite something with this x in it as something squared. And we called this process completing the square. Is everybody with me so far? And does anybody remember? Well, shoot, we could probably figure out what this is, right? Like if I get a 6x in the middle, right? What would need to be here so that I end up with a 6x in the middle? It would need to be a 3, yeah? So that I have 3x and 3x. And then if that's a 3, what would be right here? 9. Is everybody with me? And so completing the square has always been about figuring out this constant so that in the end, when I factor this out, I come back to something times itself. Is everybody with me? And to find that constant, it's half of this value squared. So far, do we feel okay? Okay, great. So when I'm looking at, say, this question, I would rewrite this question if I completed the square, what would need to be there? A 4. Is everybody with me? Now, can I just write that as a 4? That'd be so cool if I could. Nothing would be more, it wouldn't be hard anymore. But I can't just write that as a 4, yeah? So, it needs to be equivalent in value. Does everybody see why I picked 3?
Explain.
Is everybody okay?
No.
I can't tell if you're being serious or not. All right. So, I don't like you guys right now. Now, is this in one of our forms? And which one? So, yes. Which one? Okay. If they're not numbered, can we go like, oh, this is, as soon as I see this, I'm thinking arctangent. Is everybody okay?
It's 2. It's 2.
All right, so u is equal to x minus 2. A is equal to the square root of 3. Du would equal dx. Woohoo! Which band is right now?
I think it's. They're playing.
Probably middle school. Yeah, it's
Probably 6th grade.
It is.
I can tell you it sounds better than, like, what's the earliest band? 4th, 5th grade? No, 4th grade, 5th.
This is 6th right now, because
Fifth grade is recorders, I think. Wait, no, it was.
No, 4th grade is
Fourth grade is recorders. Fifth grade is the first year of
recorders. The legacy of the recorder, like since it's just the elementary instrument for whatever reason. No, there was a guy on America's Got Talent. He was
All right, how are we feeling? Okay, great. You guys, I would make this one an example where I was not confident in my answer, so I put it into Wolfram Alpha. It gave me a different answer. And I went, crap. Reworked it, got the exact same answer. Put it into ChatGPT. It gave me a different answer. Reworked it again, double checked my work. No, I still feel pretty confident. Put it into Gemini. Gemini's answer matched mine. So, you guys are getting to a level of math where if you're checking
might
your
be
stuff
wrong.
on ChatGPT, I'd be a little bit leery because ChatGPT is only as good as the people who did.
But what about Wolfram Alpha? Shouldn't that be consistent?
Well, what Wolfram Alpha gave me was a type of function called a hyperbolic trig function. And so I used to have to teach that as part of the bonus coverage. And if we don't have any snow days, second semester, I'll talk to you guys about hyperbolic trig. Hyperbolic trig is instead of being on the unit circle, you're on what's called a unit hyperbola, which is x instead of x squared plus y squared equals 0, it's x squared minus y squared. I'm sorry, x squared plus y squared equals 1 is the unit circle. The unit hyperbola is x squared minus y squared equals 1. Where you have, yeah. That's all I'm going to say about it. Like, I don't want to go much further into it than that. So Wolfram Alpha's solution, I think it was very elegant. But it assumed I was doing a higher level of math than what I was doing. And that's why it gave me the function that it did. ChatGPT had a problem with a constant, and then Gemini matched mine, so I'm going to go with that. Everybody good? All right, so this is one of those let's take a deep breath kind of problems, okay? Okay, great. All right. The first thing I would do is, in order to complete my square, I need my y squared term to be negative. Is everybody, I'm sorry, positive. So I'm going to pull out a negative 1. And now I have y squared minus 4y. So far we feel okay? All right. Guys, help me complete that square. And you need to do a plus 4. I can't just do a plus 4. I also need to do a minus 4 so that I haven't changed my value. Okay. Now, this is the part that I'm going to rewrite as something squared, yes? So I don't want this there. I want it out of the parentheses. To take that out of the parentheses, I have negative 1 times negative 4 is positive 4. And then the rest of that becomes y minus 2, the quantity squared. I'm intentionally stepping back for a second because that's kind of a crazy step. How are we feeling? Do we see why this is a positive 4?
No.
Okay. If this is negative, ignoring this for right now, this is minus this whole thing, right? So that's the minus y minus 2 the quantity squared. All right, now, if I just, now you see it? I'm gonna have to wash it. Are we okay? That stinks. This problem is why this if you guys need to throw something at me, I'm ready. Are we okay? All right, close. All right. Now what? This was the hard part, right? So we've got a equals 2, u equals y minus 2. What form is this? The 2, this is the 2 from the top, okay? Oh, du equals dy. So the 2 from the top I just pulled out front. I have du over the square root of a squared minus u squared. If you guys were wondering, ChatGPT said there should be a 1/2 here and that the 2 and the 1/2 would cancel out. I disagree with that, as did Gemini, and I don't know, something about Google being pretty smart. Everybody good? See, that was kind of fun. It's the kind of problem where I feel accomplished after I do it. All right. There we go. All right, ready? Thoughts?
There's a difference of squares within that square root.
There is?
Which is nice.
Okay, so that might make us want to do.
Factor it, then. Wait.
I'm really wishing I would have worked this one in advance. Thought? Anyone? You want to pull out an x plus 2? So I am comfortable rewriting that. I am flying a little bit blind here because I didn't mark this. It'd be x plus 2 at x minus 2. And we can go. What we can do is go ahead and put both of those to the 1/2, right? I don't know if that helps us.
Yeah.
It would get us so we would have on top we'd have x plus 2 to the 1/2. And on the bottom I would have x minus 2 to the 1/2.
Within the root on the bottom, what should we do? Fill in the number minus 4x plus 4x to start.
Say that one more time.
I don't think like that. I don't think you do that.
Any other ideas? What's Kenny's idea? You sub it at the beginning? Like say u equals 4 minus x squared? Is that what you're saying? Was this the idea?
I think we should just split the integral into two parts. Which we.
You guys. Kenny, tell me what to do.
Break the integral into two parts. Make it the integral of x over the square root of 4 minus x.
That's
squared.
exactly what you're supposed to do, Kenny.
And then plus the square root of 2 over square root of 4 minus x squared.
Like this?
Yeah.
I think that's a great idea.
Yeah.
Does everybody see it?
How you do that?
Now what?
Solve the first integral.
Solve this.
All right, great. How do you guys want to do the first one? The first one's not bad. U sub. U equals 4 minus x squared. Du equals negative 2x dx. So negative 1/2 du equals x dx. First one's not bad. You guys, there's like the guy jogging on the track right now. It's just like, if he was in a gray hoodie, that'd be amazing. Hey guys, what's the integral of 1 over square? Rocky? It's a Rocky reference? Because they're playing Rocky in the auditorium. And then Rocky's training in his like gray sweatsuit. And he's running up the hill and those stairs in Philadelphia. No? I mean, I haven't seen Rocky since well before any of you guys were born.
It's certainly aged.
When did you see Rocky?
Most people assume he wins at the end of Rocky. Hey guys, what's the integral?
I would have thought he did even if I've seen it. I don't remember that, but I guess.
It's
Surely he did.
it's actually, well, so the integral of u to the negative 1/2, if I put that exponent up by 1, I get u to the positive 1/2 times 2 times the negative 1/2 out front. Everybody good? So I've got negative u to the 1/2, which is negative 4 minus x squared to the 1/2. Hey, Kenny,
Yeah.
Reese cup or take 5?
Probably take 5.
Ooh.
Very.
Oh, wait a minute, wasn't I supposed to put these out for you guys on Friday?
Yeah, the quiz. Ooh.
I got bad shoulder. I forgot to put those out for you guys. Grab one on your way out. Hey, for this one, y'all. For this integral, we're gonna do a equals 2, u equals x, and in fact, because of that, we can kind of ignore and not have to do that full substitution, right? As long as So I have the 2 on top. That's that 2. Okay. And then which form is this one? So I have arc sine of x over 2 plus c. That's my final answer.
Guys, inspirational back here.
You guys, what about this one?
Let's put this one out, okay?
Times get tough now.
This one looks a lot worse than it is. Just let u equal cosine x. du equals what's du, y'all? Negative sine x dx. So negative du equals sine x dx. We'll let a equal the square root of 7. Now I have negative du over a squared plus u squared equals, which is arctangent form. So we'll have negative 1 over square root 7 arctan of cosine of x over the square root of 7. Let's leave the definites for tomorrow. So we'll do these last 2 examples tomorrow. Friday review for the quiz. Quiz will be Monday. If you would like